So, what if I told you that language has a hidden architecture, an underlying blueprint that we can actually map out? Well, today we're going to pull back the curtain and reveal the secret scaffolding that holds all of our sentences together.
Let's start with a little challenge. Imagine your task is to analyze a language. Map out its entire structure, but there's one giant constraint. You are not allowed to use the meaning of any of the words. How would you even begin? I know, it sounds pretty much impossible, but for a whole group of linguists, this was their entire project.
To really get this pretty radical idea, we have to rewind the clock to the early 20th century. This was a time when our whole understanding of language was getting turned completely on its head. Scholars started to stop seeing language as just a big dictionary of words and started seeing it for what it really is, a complex, deeply interconnected system.
You see, the old way of thinking was what we'd call item-centered. A word like dog just meant, a dog. Simple. But the new structure-centered view, that was a total game changer. It said that a word's real importance comes from its place within the system, how it relates to all the other pieces on the board.
Now, this structural idea was taken to its absolute logical extreme in the 1940s and 50s. A new school of thought popped up that aimed to build a grammar based purely on science, completely detached from all the messiness of human meaning. They called it taxonomic grammar.
At its heart, taxonomic grammar is all about classification, or taxonomy, right? Think of it like a mechanic who's mapping out an engine. They can show you how every single piston, gear, and wire connects to every other part, all without ever asking where the car is driving. It's not about the destination, the meaning, it's all about the machine itself.
So what were the ground rules for this? Well, first off, you had to focus only on form. That means the shape of a word and where it can physically fit in a sentence. Then you classify words based on those positions. The main goal was to break sentences down into their smallest possible parts, all based on the belief that every language has its own unique internal logic that you have to map out on its own terms.
Okay, but how do you actually dissect a sentence this way? The main tool they used was a method called Immediate Constituent Analysis, or ICA for short. And honestly, it's a little bit like performing linguistic surgery.
All right, let's put a nice, simple sentence on the operating table. The teacher will read the book. Using ICA, our job is to slice this thing into its fundamental parts, one cut at a time. The first and biggest cut always divides the sentence into its two main parts. So on one side, we've got the teacher, that's our subject, and on the other side, we have will read the book. That's our predicate, the action that's being performed. And the process just keeps going. We keep on slicing, breaking each chunk into smaller and smaller pieces. So will read the book gets split into will read and the book. And you keep doing this until you're just left with the individual words. Seems straightforward enough, right? Well, not always. This cutting method works just fine for really simple sentences, but it hits a massive wall when it runs into ambiguity. When a phrase can mean more than one thing, the whole system just breaks down. Take a look at this phrase right here. Old teachers and students. Our simple cutting method gets totally stuck here. Why? Because the structure itself is ambiguous, and the system has no way of knowing how to group the words in the right way. Just pause for a second and think about it. What does old teachers and students actually mean? They're two completely different meanings packed into just those four words, and our cutting method can't tell them apart at all. So here are the two possibilities. In one interpretation, only the teachers are old. But in the other one, everyone is old, the teachers and the students. The problem is that both of these structures are grammatically possible. A simple cutting tool has no way to decide which one is correct, because it's completely blind to the deeper relationships between the words. So how do you fix this? Well, linguists realized they needed another layer of information. It wasn't enough to just cut the sentence into pieces. They had to give each and every piece an identity. The solution was actually beautifully simple. Give every single part a label. And these are the kinds of labels they used. S for the entire sentence. NP stands for noun phrase, which is just a chunk like the teacher. And N is just a single noun. Each label acts like a little tag, adding a crucial piece of data to our structural map. And this is where it all comes together in what's called a tree diagram, or a phrase marker. This is the ultimate blueprint of the sentence.
It's a visual map that shows you exactly how every single element connects, branching all the way up from the individual words to the complete sentence, that S at the very top.
So for our original sentence, this diagram makes the structure crystal clear. You can see the main sentence S splits into two big branches, a noun phrase and a verb phrase. And then each of those breaks down even further. Every single component has a clearly defined place and a label. With a map like this, ambiguity is suddenly no longer an issue.
So by combining the cutting with the labeling, and by focusing only on form and distribution, the structuralists created a way to map language with scientific precision. They completely bypassed the subjective, messy world of meaning to reveal the clear, formal blueprint of the system itself.
And this leaves us with a really fascinating final thought. If language, this thing that we all use every single day, has such a deep and hidden architecture, a blueprint that exists completely independent of meaning, what does that reveal about the fundamental structure of the minds that create it? Thanks for joining me on this deep dive.